For my project, I'm exploring the use of BLM, an acronym for Black Lives Matter, and its use in social media, specifically across the Twitter platform. I'm going to be examining the use of BLM over one day and mapping its popularity throughout the country. I'm going to be collecting data from the US Census to find the 75 most populated cities. And with those target cities, I'm going to be using Mapbox to extract the coordinates via reverse geocoding. And then I'm going to use these coordinates to run a geospatial search for tweets by location and the search term BLM. And then finally, once I have those tweets, I'm going to be further refining the search and the tweet results by user profile location. This is so I can target the actual residents of the cities instead of tourists or people who may be moving through the city, or even Twitter users who are not in the city at all, but just geotag the city location. The BLM movement has been in the spotlight this year, and use of BLM and Black Lives Matter has exploded over Twitter and other social media platforms. It's my assumption that the use of BLM would equate to support for Black Lives Matter movement, and cities with higher use of BLM in tweets would equate to more support for the Black Lives Matter movement, which made me interested in this project to see where and in what cities across the country had the most use of BLM as a proxy for support of the Black Lives Matter movement. I'm going to be collecting data from the US Census Bureau, geographic coordinates from Mapbox, and then tweets from the Twitter API. So my first task was to collect the US Census data and find out what the most populated 75 cities in the country were. So after I accessed the website and the data set, I downloaded the data for cities and population. And then I sorted it and saved only the top 75 cities in the country based on population. So here we have the list of the top 75 cities throughout the country. These are going to be my target cities for analysis. Okay, so once I had my list of top cities, then I needed to get the geographic information from the cities. So I used Mapbox, and I used the city name to input into Mapbox to find the top results for each city, and then I saved those geographic coordinates. And now for each city in my top cities list, I'm going through and searching Mapbox using the city name, and then extracting from the top result, extracting the geometry, the coordinates. And this is what the results will look like so far in the data frame. So now I need to split the coordinates into separate lat and long columns. So here is a little iterator that I created for each city or row in top cities. It's going into the coordinates column and extracting the latitude from the coordinates and saving it in the latitude column, and extracting the longitude and saving it in the longitude column. Okay, so at this point I have basically all of my cities information. I have the top cities and their population that I got from the US Census, and I have their geographic locations from Mapbox. So now what I need to do is actually go into Twitter and actually search for the tweets in these locations. So the free version of the Twitter API that I was using had some pretty significant limitations in its capability. So this presented some issues that I really had to think through about how I was going to get results returned for tweets originating out of the city, each city, and not beyond the city, because I wanted to normalize the tweet results for each city by the city's population. So my solution was as follows. At first, I cast a really wide net that extended the search results beyond even the largest city's geographic location. So I did this by using the Latin long coordinates that I found above and input those into the Twitter API search. I used a 30-kilometer radius to, this would ensure that my search of tweet results would extend beyond even the largest city. So a 30-kilometer search radius might be appropriate for a city like Phoenix, Arizona, which is very large, but using a 30-kilometer search radius for a city like San Francisco, you would get tweet results from Berkeley and Oakland, and obviously these are different cities than San Francisco, and those results shouldn't be included. So once I had my large geographic search results of 30 kilometers, then I needed to narrow down those results and filter out the tweets that weren't actually originated from the target city. So what I did was go into the Twitter user profile location. This is basically the home city of a Twitter user that they save in their profile. So if a Twitter user self-reported in their user profile that they were from a certain city, then I use that to verify the authenticity of the tweet. So if a tweet was geotagged in San Francisco and the user profile location was also San Francisco, then I would assume that that tweet was being sent out from a resident of San Francisco. So this filtering was an attempt to get tweets from the residents of a city as a way to authenticate that the tweets were actually coming from that city and from residents. This is important because the US Census data population is based on residents of a city. Okay, so now I'll go through and just show you what I did. Installing and setting up Twitter and my keys. And here I'm setting up an empty data frame, which I'm going to populate with my data of interest being the cities, the total tweet count, and retweets just for interest, and then tweet count, STS, and retweets STS. This is going to be for a comparison at the end. Okay, so Twitter only allows a results from the past week, and they only return results up to 100. So if there were 200 tweets from a city, I would only be seeing 100. So I didn't want to. I had to change my search criteria, so I wasn't maxing out my tweet results and leaving some tweets off the table. So I pivoted from looking at the entire week of tweet results to just a one-day span. And using just a one-day span, most cities, if not all cities, had fewer than 100 tweets. So I was safe in assuming that I got that I had collected all of the tweets from a city and wasn't leaving any out. So Twitter uses a 7-day search frame for results. So to get a one-day slice, I basically found the date from 6 days ago and then input that into my Twitter API search. So it would only allow results from between 7 days ago when the Twitter API starts and 6 days ago from today. Okay, so with all this information, I am ready to actually access the Twitter API and run my search. So this is the heart of my search. The search parameters are BLM, that's the term I'm looking for. The geocode equals chords input, which I'm extracting from my cities table, Latin long. And then I'm adding the 30-kilometer radius, which I described previously. And then until, this is the tweet date, which I calculated before. This is 6 days ago. And then the count is 101, just to ensure that I am maxing out my Twitter results of 100. Okay, so here are the results of my table. The cities, the tweets that match BLM coming out of each city, retweet count, and then user location. This is really the column that I'm interested in. User location, I considered the tweets that were verified coming out of a city location based on city Twitter user city residency. Okay, so then I repeated this Twitter search with the exact same parameters, but instead I input stop the steal. So this is in reference to conspiracy theorists who think the election was stolen from Donald Trump. There's a hashtag trending, stop the steal, which refers to that idea. Okay, so in comparison to the popularity of BLM tweets across the country, I'm going to look at the popularity of tweets that mention hashtag stop the steal. Okay, there it is. Now we have our tweet search results by city and just adding the short city name to the table. Okay, so now after I have assembled all my tweet information by city, I'm just going to merge the population table. And then because there's so few tweets compared to the city population, I'm going to be looking at tweet count per 1 million residents. So that's what I'm doing here, a little bit of math to convert to get the numbers for tweets per million residents. Okay, so now I have all of my results, and taking a brief look at it, we have the city names, we have the tweet information data, and then we have the tweets per 1 million residents of the city for both BLM and Stop the Steal. Okay, so now I'm going to visualize this data so we get a better understanding of it. Okay, so let's first just take a look at the population of each city. And I filtered my results here for just the top 20 cities because plotting 75 cities was just impossible to read. So here you see that the population of New York is by far more populated than any other city. So to compare the tweets coming out of the cities, we had to normalize it by population. So let's take a look now at just the initial results of the tweet count when we only consider a 30-kilometer radius around the geo-coordinates for each city. So this is the total tweets. So this is the total tweets coming out of each city within a 30-kilometer radius. So LA is nearing 100, not exceeding. That's good. Otherwise, we would have left some uncounted tweets in the search. Seattle, Washington are also high, so are Chicago. Okay, but again, this is the total tweet count from within a 30-kilometer radius. So if we then take those results and filter them out and only look at the where the user location matches the city results from the previous search, this would be a more accurate way to look at tweets from the residents of the cities. So now we see that LA has dropped in tweets by residents, where it was did have the most tweets by geotag. Chicago now has the most tweets by residents. Washington, D.C. is much lower than what it was before. So is Seattle. So this is now the count of tweets matching BLM by residents of each city and originating from the city. So these are the results of a single day search for BLM with a geotag location of a city and being sent by residents of each city. So this is the data that we're interested in, but now we have to normalize for the population. Okay, so let's just map the tweets per 1 million residents. And now we see that Boston has the most BLM tweets per million residents. San Francisco and Austin are also quite popular. And these are going to be the results of a one-day search. So it's going to be dependent on the specific time that you run the search and what we're looking at here, and possibly what you see when you run the search may be different. And my text may not match up entirely perfectly, but I would assume that the trends would be generally the same for popularity of BLM and city. So one limitation of this would be the matching of the user location to the city. For example, Dallas and Fort Worth are essentially one city, but for tweets coming out of a geotag location of Fort Worth, if the Twitter user indicated in their profile a location of Dallas, then those tweets wouldn't be recorded as verified coming from that location, and they wouldn't be counted. Also for New York, possibly users reported specific neighborhoods or cities like Manhattan or Brooklyn. And if they didn't include New York, then those tweets also wouldn't have been counted. And also maybe people in Los Angeles might have listed Malibu or some other city instead of Los Angeles, and then those tweets would have been filtered out. But anyways, I think this is a reasonable representation of tweets that mention BLM per million residents by top cities in the US. And now the next step is to look at this geographically on a map. So here I'm just importing Mapbox and getting that set up. Keys and tokens, and doing a little bit of formatting and creating a GeoJSON data frame. And then for reference, this is the data frame that we're converting to a GeoJSON and the information that I'm going to display on a map. Okay, so first let's display or visualize the BLM popularity across the US. So I'm looking at tweets per million residents for the top 75 cities in the US. And I'm symbolizing here in color tweets per 1 million residents, and then in size of the symbol is the population of the city. So this is displaying popularity of BLM in top 75 cities across the US. So it's most popular in places like Portland with almost 40 tweets per million residents. Minneapolis and New Orleans has almost 72 tweets for BLM per 1 million residents. This wasn't shown in the graph before because it's not one of the top 20 cities based on population. And for trends, it's not so popular in the Southwest, New Mexico and Arizona. And it's also not very popular in Southern California, which was somewhat surprising to me. BLM tweets seem most popular in the Pacific Northwest, Texas, which was a bit of a surprise to me. And then in the Northeast, across different locations in the Northeast, and it has mixed popularity around New York and in DC and New England. And then now for a comparison, let's map the Stop the Steal hashtag on Twitter using all of the same search parameters and symbology. Just mapping Stop the Steal per million residents of each city. So Stop the Steal is most popular in places like Cleveland, Ohio, with 28, almost 29 tweets per million residents. And Atlanta, Georgia, with 36 tweets per 1 million residents. Atlanta was surprising to me until I remembered that Georgia is one of the states that is being contested in this ongoing election debate. And Las Vegas, which has 12.5 tweets for Stop the Steal per million residents. Another interesting comparison to make is using all of the same search parameters and symbology. We can compare hashtag Stop the Steal to the popularity and use of BLM across the US. And we see that BLM is much more popular among Twitter users, and BLM is getting used much more on Twitter than Stop the Steal. So hashtag Stop the Steal tweets would indicate support for President Trump. And considering that Twitter is President Trump's social media outlet of choice, I find it a bit of poetic justice seeing that Stop the Steal is less popular within Twitter than BLM. So I hope you enjoyed this walkthrough and these visualizations. I thought it was a fun exercise to examine social justice issues through the frame of social media. Thank you.